Okay, class, today we're going to do lab 3 on frame relay. Okay, so this is the network topology. Okay, let's remove the map first. Okay, this is a network topology. Okay, so I'm going to use the other side. Okay, I created the network topology here. Okay, so we have 3 routers. R1 is connected to its own local area network, 192.168.10. R3, 192.168.30, and R2 is connected to the internet. R1, R2, and R3 are all connected to the frame relay. Okay, so today we're going to try to configure the frame relay on these 3 routers so they can talk to each other. Okay, so let's look at the first task. Okay, this is the IP address, and then task 1 is supposed to configure the IP address on the router interface. So based on this table, you configure the IP address for R1 000, R2 for the both serial line, and R3 FA00 and 0000. So make sure you configure all the IP address and do a no shut on the interface. Okay, so that's for task 1. Okay, task 2 is on RIP. We hope you all still remember the RIP routing protocol. Okay, the command is actually very simple. Okay, go to router RIP on each of the router. So router RIP. Okay, and then configure RIP to advertise the network that this router R1 is connected to. Okay, you can see the R1 is connected to 2 networks. Okay, a 10 dot network and a 192.168.10 network. Okay, let's go to the network diagram again. Okay, again, R1 is connected to this network, which is the 192.168 network, and R1 is also connected to the 10 network. Similarly for R3, 192.168.30 network and the 10 network, okay, via the serial link. For R2 is a bit different. R2 is connected to the ISP and also to the 10 dot network. Okay, let's go back and look at the RIP configuration. Okay, so R1, router RIP, network 10.0.0.0 and 192.168.10. So we are telling R1 to advertise these 2 networks to all the RIP routers. Similarly for R3, okay, R2 will be a bit different. Okay, R2, one end of it is connected to the ISP, the other end is connected to the 10 network. So we ask R2 to advertise the 10 network. Okay, we also configure the static route. Okay, and this static route is what we call the default route or the gateway of last resort. Okay, so we have 0.0.0.0, 0.0.0.0. Okay, and the exit interface is 0001. Okay, what this command does is tell R2 if it receives a packet and it doesn't know how to route the packet, send it out via the exit interface 0001. Okay, if you look at the diagram, okay, so R2 0001 is connected to the ISP. So any packet that R2 receives and do not know how to route it, just send it to the ISP. The ISP will help him to route the packet to the internet. Okay, so that's a default route or the gateway of last resort. Okay, next we have a command called default information origin. Okay, basically this tells the router R2 to advertise this default route to all the other RIP routers, Okay, let's look at here. Okay, so R2 will advertise its default route, okay, to R3 and R1. So after configuring default information origin, R1 will have a default route and it will point it to R2. R3 will also have a default route and it will point to R2. Okay, this default information origin command is very useful if you have many other routers. Okay, so by running this default information origin command, R1 will also advertise the default route to all its RIP neighbors. And the RIP neighbors, the new routers, will automatically insert a default route, okay, that send the packet to R1 and then all the way to R2. So imagine you have a lot of routers. All you need to do is configure one command, the static route, and the second command, the default information origin. Okay, then all the other routers will have the default route automatically. Okay, so that's the end for task 2. Okay, in the next video, we'll look at task